Okay, so problem number 3 says the spring has an unstretched length of 0.3 meter. Determine the mass and for each of each uniform length, if angle theta equals 20 degree for equilibrium. Okay, so this is a spring constant type of frame problem. Okay, first thing we notice that there's 2 supports and 1 hinge. Hinge at C, pin support at A, so it means that has 2 reactions, AX and AY. And at E, we consider that as a roller support, so which means that I only have 1 reaction, which is the one that with contact to the surface, so EX, and doesn't have any EY. So first, we have an unstretched length of 0.3. That's for the spring constant. Let's find out what's the stretched length. So let's consider if this is half of the stretched length. Let's call it Y. Okay, and then we have angle theta 20 right here, and this is 0.6. Okay, so do our math. So we get Y will be equal to, right? So let's do sine 20 equals opposite, which is Y over the adjacent 0.6. So we get Y is equal to 0.6 sine of 20. Okay, so that's for this part of the stretch thing. And since they're symmetrical, because the angle, these 2 angles are the same, so we know that top and bottom are symmetrical. So we are also able to determine what's this part of this stretch length. That will be just 2 times the Y. So Y, just let's call this Y1. So the actual Y will be equal to 2Y, which would be 2 multiplied by 0.6 sine of 20. So we get Y will be equal to 0.41 inch. Oh, my bad, not inch. That's meter in this case. Okay. Yeah. Next thing, let's find out what's our spring constant forces. So we have spring constant force F is equal to Ks. In this case, the Ks is the difference between the stretch length and unstretched length. So that's like how much did you stretch this thing? Okay, so K is 400 multiplied by stretch length 0.41 minus the unstretched length. Okay, so I got F equal to 44 newtons. All right. Next thing what I have to do is that I have to determine what this length right here is. So previously we determined the Y for the spring constant, right? But right now we need to consider the Y between A and E. So let's draw that. Let's call this Y2. Okay. And then this distance 0.7, also 20 degrees. So do our math, we get Y2 will be equal to 0.7 sine of 20. But since this Y2 is only for this portion, we also have to consider this portion as well. So it's very easy. We just multiply by that by 2. So we get, so let's say Y3. So it's this distance. Let's call this Y3 is equal to 2 multiplied by 0.7 sine of 20. I get Y3 will be equal to just 1 point or sine 20 calculator. So 0.48. Okay. Right now, let's do. Okay. Next thing we're going to do is that go back to the problem. We can tell that the problem says determine the mass of each uniform link. So the mass, we know that for this rod will always be at the center. So at the center, right here. Okay, so let's draw this as well. It's 0.7. Okay. And we know that half of this distance will be 0.35, right? And this one right here, just half of 0.48. Okay. So first, what can we do at this point? So we know that from now on, we do everything in terms of using the equilibrium. So we have three equations to use. But right now we're going to use the moment equation because we don't know any forces in AY, AX, and EX. So what can we do to reduce down the unknowns? Well, we can take moment. Where can we take moment at? Well, we always want to take moment at the support that with the most unknown, which is A in this case, because at A we don't know what AX and AY is. But E, we only have one unknown. So if we take moment at A, then we can get rid of the AX and AY, leaving us to find out what E is. Okay, so let's do summation of moments at A equals 0. So I have my EX. So multiplied by the perpendicular distance, which is this Y3 right here, 0.48. And then we have to minus those two weights right here, which since they're the same, so I'm just going to say 2 W, where W is equal to mg, right? And then multiply by half distance, which is 0.35. A is right here, and W is going down, so we need to, it's a perpendicular distance right here. So it will be 0.35 cosine of 20. Okay. I'm not sure if I can confuse you guys at this part, but let me redraw this. So this is 0.35, right? And we know that this angle right here. And since W is going down right here, and A is right here, so we require perpendicular distance, which in this perpendicular distance will be this distance right here. So this X will be 0.35 cosine of 20. But let's say if W is in the X direction, then it means that this X will be equal to 0.35 sine of 20. I'm not sure. Yeah, I confused you guys. Okay. And then equals 0. And then we solve to get EX. So we know that G is equal to 9.81, right? So that's EX 0.48 minus 2 multiplied by 9.81 m multiplied by 0.35 cosine of 20 equals 0. And you get EX equal to 1.37. Hold on. Let's keep that G right there as of right now. Let's keep that G. So we get E will be equal to 1.37 mg. Okay, let me keep that as of right now. Next thing, what we have to do, well, we have to find out what mg is. Well, we know that here's a hinge. So for hinge, we can separate these two rods into two free body diagrams. We're gonna ignore the free body diagram right here because we don't know what AX and AY is. So we're only gonna consider free body diagram of EX to C. Okay. So here's C. C is a hinge. So it has two internal reactions, CY and CX. And we determine what EX is, which was 1.37 mg. And on this rod, we have two forces right here. So one is the weight at the center, okay? 5. And then the other thing is this um, spring constant force right here. Okay. And then for that, you know that this distance of 0.1 right here and 0.6 right here, right? Okay, right now we can take a moment at C because C has the most unknown. Okay, initial moment at C equals 0. So we have our EX, which is 7, multiply by this distance right here. So 0.7 sine of 20 plus mg 0.35 cosine of 20 minus 4 0.6 cosine 20. Okay, equal to 0. All right, then if we reduce this equation down, we're going to get 0.66 mg equal to 24.8. And then we solve for g. So mg will be equal to 37.86. And then m will be 37.86 divided by 9.81. So we get m will be equal to 3.86 kilograms. Okay. So that's the mass for each of the rod. All right, guys. So that's all for problem number 3. So these 3 problems that I went over will be the type of problem that you put on the previous one problem for this final exam. The next 5 problems will be on multiple choice.